Definition of impulse and momentum. Okay, linear impulse and momentum principle. How do we derive the principle of impulse and momentum? Okay, let's have a look on these definitions. What is momentum? We start with the momentum. So it's defined as mass in motions. If an object is in motions, which is on the move, then it has momentum. So mass in motions, any object, physical body which is in motions, it has impulse. It has momentum. If no motion, no momentum. The simple thing that we can put in our mind is no motions, no momentum. If if we have any motions that occur on any physical body which is in on the move, so that kind of body is undergoing so called it has momentum on that kind of body. That is the simple thing that we can put in our mind. So the amount of momentum which an object has is depend upon two variables. It refers to the quantity of motions that an object has. The first one is the mass of an object or physical body, and the second one is the second quantity or parameter which need to be considered is the velocity. How fast the stuff is moving. So in terms of equations, the momentum is equal to mass time velocity, which can be symbolized as P. P is equal to small letter of P is equal to mv. So this is the what's so called common symbol for the momentum, which come from Latin word, which it means that push or drive. So P is equal to mv. P small letter of P is equal to mv. P itself is the common symbol of momentum. So the equation illustrated momentum is directly proportional to object mass and proportional to object velocity. So P is momentum, M is the velocity, and M is mass, and V is velocity. So dia berkadar terus. The equation illustrates that momentum is proportional to object mass and proportional to velocity. Momentum is proportional to M represent on mass. Let's say this one is P represent on momentum. Dia berkadar terus like this. Similarly to this what's so called velocity. The higher the velocity is, the higher the momentum. Dia berkadar terus juga like this. The momentum of any object which is at rest is 0. It means that no object at rest do not have momentum. They do not have any mass in motions. It means that any object which is at rest, they don't have any momentum. Okay, here's the just check for understanding on how do we apply the momentum. How do we calculate the momentum? It means the momentum of a 60 kilogram half bag moving eastwards at 9 meters per second. So by using the equation of, let's say for the first one, A, P is equal to mv. This one is a straightforward punya soalan lah. 60 times 9 is equal to 6 kali 9, 440 kilogram meter per second. 20,000 kilogram meter per second. And then for C, P is equal to mv 40 kilogram. Brushman moving southward at 2 meter per second. For this 80, 40 times 2 is equal to 80 kilogram meter per second. Last one, the 50 kilogram bucket which is at rest. P is equal to mv 50 times v at rest, it means that v is equal to 0 meter per second. So no momentum on this bucket. Okay, next, a truck possesses 30,000 units of momentum. What would be the truck new momentum if its velocity was double? P is equal to mv, the basic equation for that. And that one is equal to 30,000. The momentum for the truck is 30,000 units. Momentum, unit of momentum, you can put any, let's say, kilogram meter per second. Contohnya kan. So what would be the truck new momentum if its velocity was double? P is equal to mv. If the velocity is double, the first one, P is equal to m to v. The velocity is double, right? Time 2 is equal to 2 mv. We do right? V. So mv, now that when v is equal to 30,000, then we can put into this equation, substitute 2 times 30,000. So you got this 60,000 units of momentum. That's for A. B, its velocity was triple. So mean that P is equal to M 3V. Triple, right? V plus V plus V 3 times. Or we can rearrange this equation, 3 multiplied with mv. So that one is equal to 3 multiplied with 30,000. So you got this P is equal to 90,000 units. If mass was double, the same stat can be applied as A and B. It means that P is equal to mv, P is equal to 2m multiplied with V. So you got this P is equal to bracket NB, and you got that one is equal to A, 60,000 units. Both velocity and mass was double. You can try to do it by yourself by using this basic equation for the momentum. Okay, the next is a method of work and energy. U1 up to 2 is equal to T2. T is equal to half M V1 to the 2 plus F ds is equal to half mv 2 to the 2. So method for work and energy, it relates force, one force, mass, one, velocity, mass this one and also this one lah. Okay, velocity means that v1 and v2 and v2 as well, and displacement which is ds. Displacement this one. So this is concerned about the principle of work and energy. It's involved mass, velocity, force, and also displacement. Whereas for the method of impulse and momentum, it relates force, mass, velocity, dan juga time. So the different di antara keduanya adalah satu displacement, satu lagi masa time. Kita akan lihat nanti. An object with the momentum is hard to stop. Here is the example for that lah. In football, the defense player apply a force for a given amount of time to stop the momentum of offensive player with the ball. Here is the example of this application of momentum. And this so-called the offensive player move to the rightwards. The defensive player try to hold stop this so-called this offensive player to move forward. So here is the example of momentum lah. Okay, the next is impulse. Tadi tu momentum, equation dia adalah P is equal to mv. Yang seterusnya adalah impulse. It can be defined as a change in its momentum. It can be defined as a change in its mean that particle object momentum. It can be symbolized as J or IMP. So we can use the equation of G is equal to F mdt or IMP is equal to F times dt. So both of this is the common symbol of so impulse. Impulse. So it measures the effect of force during the time the force act. So dia ada F force dan juga dt. So the impulse is can be defined also as an integral of force at an interval of time t. At an interval of time t. The integral of force and time. The impulsive force occur due to the explosions or the striking of one body against another body. For example, is hammer striking the stake, concrete chipper hit the concrete, and so forth. So here is some of the example of impulse is equal to F time dt. Okay. So here is how we obtain or derive the equation for the principle of impulse and momentum. So by using the basic equation of kinematic equation or Newton's second law of motions, which is sum of F is equal to ma. So here is the kinetic equations of motions. And also we need to consider another one equation, which is A is equal to dv over dt as the second equation, which is this one is variable kinematic equation of motion for the second one. So the combination of both, at the end, if we derive, we can obtain another one equation, which is called as principle of impulse and momentum. As you can see here, we have the equation of F is equal to ma. A itself is equal to dv over dt. So we substitute these 2 into A into equation 1, 2 into 1. 2 into 1, which means that sum of F is equal to M. You know that A is equal to dv over dt. Just substitute it in this equation and we rearrange this. Sum of F times dt is equal to M dv. So once we got these equations, what we need to do is integrate both left and also right side. As you can see here that I can write it down simply like this as well. F times dt t1 up to t2, for example, is equal to m dv v1 up to v2. So if we integrate, let's say, the right side of this equation, m dv, you can get this mv2 minus mv1 at the end. Okay, and therefore this one f dt v1 up to t2 is equal to mv2 minus mv1. So if we rearrange this equation, put this mv1 to the left side, so we can get this mv1 plus f dt is equal to mv2. Okay, so this equation we call it as a principle of impulse and momentum. As you can see here, the one this or we can write it down as mv1 plus imp 1 up to the 2 is equal to mv2. What does it mean? So we call it as a principle of impulse and momentum. Final momentum of the particle is mean that mv2 can be obtained by adding vectorially its initial momentum. It means that initial momentum, this one, initial momentum, which is mv1, and impulse of the force during the time interval. It means that this one, impulse of force during the time interval force, and also what is the time interval that we consider. That one is equal to the final momentum, mv2. Okay, so my dear, when we talk about this principle of impulse and momentum, it relates mass, velocity, force, and also time. Time dt. Dt represent on time. Itulah persamaan yang perlu diguna pakai when we deal with this what's it called, impulse and momentum, right? So we can, if we consider on these two degree of freedoms, we can write down the equation for the impulse and momentum as we can see here. Okay, the f x dt is equal to integral of f x dt between t1 up to t2 is equal to m vx2 minus m vx1. Or we can write it down as m vx1 plus f dt is equal to m vx2. We need to also put the positive sign conventions. Let's say we put or we consider that positive to the right word. Okay. So here is the principle of impulse and momentum equation. When we consider on these x directions, ini adalah x, si x, dan juga si y. And if we consider on these vertical directions, we can use this equation of sum of integral of fy dt is equal to m vy2 minus m vy1. Okay, ataupun we can write it down as m vy1 plus fy dt is equal to m vy2 positive upward. If we consider on the z directions, 3 degree of freedom, for example, then we can use this equation. Sum of the integral of sum of f d dt is equal to m vz2 minus m vz1. Okay, quite simple as well for the principle of impulse and momentum. Is there any question before we continue with this class? Yeah. Okay, the next is conservations of momentum. mv1 plus imp 1 up to the 2 is equal to mv2 if resultant force, this means that this one, if resultant force of a particle is 0, this means that imp 1 up to the 2 is 0. No impulsive force. And or there is no external force applied to the particle, assuming that this imp1 up to the 2 is equal to 0, then mv1 is equal to mv2. This means that the momentum is conserved if no external forces apply to the particle. The momentum of the system is conserved. So we can write down the equation of mv1 is equal to mv2. mv1 represent on the initial situations or conditions, and mv2 is the final. Okay, therefore we can write down the equation mv1 is equal to mv2. Okay, let's have a look on this example 1. So example 1, the 100 kilogram stone is originally at rest on the smooth horizontally surface on the smooth horizontal surface. Which means that if they say smooth horizontal surface or smooth surface, it means that no frictional force. No frictional force. If a towing force of 200 Newton acting at an angle of 45 degrees, as you can see here, which is applied to the stone for 10 seconds. They give you time t, which is 10 seconds within the time second punya movement ataupun pergerakan. Determine the final velocity and normal force which the surface exerts on the stone during the time interval. So as usual, when we deal with this kind of problem, the initial step is course you need to draw the free body diagram. Let me add a blank slide. Okay. So they ask you to find out what is the velocity, the final velocity, and what is the normal force. So as usual, for the solutions, you need to draw the free body diagram. Solution. Draw FBD, free body diagram. Okay. Draw the free body diagram. So we have this stone, and the mass of the stone is equal to 100 kilogram. Stone. So the mass is 100, which means that W is equal to mg 100 and times 98.1. We've got this 981 Newton meter or joule. Sorry. W is equal to mg. Mass adalah 100 kali dengan 9.81, kita dapat dalam Newton lah. 981 Newton, sorry. 100 kali 9.81 kan. And 81. That's W. Okay, the next is the force. What is the angle? So it's stated that the angle is equal to 45 degree and the external force is equal to 200 Newton. 200 Newton. The towing force. This one is 45 degree. And we have the normal force. NA. What else? Yeah. So of course you need to draw the free body diagram showing all of the forces which act on this physical body, or which in this case is stone. And if you look at this illustration, so it has the potential or possibility move to the rightward, of course, based on these illustrations. So it has the velocity of V and also acceleration of A. You can also find out this one. And it is given that the time which is given is equal to 10 seconds. acting at an angle of 45 degrees is applied to the stone for 10 seconds. It means that the within 10 seconds. The T is equal to 10 seconds. So that is the first step. So the second step is apply the principle of work is work like impulses. Apply the principle of impulse, of impulse. And so we consider on the directions of x directions. So mv1x plus f dt is equal to mv2x. So based on these illustrations, we apply the forces which act on this stone by considering on two directions, which is horizontal direction and also the vertical directions. Okay, what you need to do is just substitute into these equations m mv1x. We stated that start from rest. Start from rest. Mass dia adalah 100 kilo. V1x is equal to 0 plus F. The impulsive forces in the x direction. So we have this 200 Newton to the rightward. Consider on the component of force itself. So 200 cos 45 degree. 200 times cos 45 degree. What else in the x direction? Only this one that yang ni NC pada y direction, W also in the y direction. So kita hanya ada this 200 Newton external force. So it's equal to M is equal to 100 kilo kalikan dengan this V2. V2x V2x. Oh V2 lah. V2x. So in this case, we only have one unknown, which is V2x. So since we only have one unknown, then we can straight that direct or obtain the result for the V2. V2x is equal to V2. Vt is equal to V2x is equal to bila you selesaikan, you akan dapat jawapan dia lah. As we can see here, V2 is equal to 14.1 meter per second. Okay. So this is the first one. So the second step is we consider on the y direction as well. Okay. Okay, yang ni adalah A lah. Adalah A. Yang B adalah MV1Y ya. MV1Y plus Fy dt is equal to MV2Y. Okay. So we consider on the y directions. MVY1 or MV1Y is equal to MV1Y plus Fy dt is equal to MV2Y. Positive Y upward for this case. So we look back on our illustrations. What is Y direction? So Y direction tu ada tiga which is NA, W and also component of force 200 Newton in the Y direction. Okay. So makna dia, if you look at this, NC tolak W plus 200 sin 45 degree. Okay. So we just substitute into this M, sorry. Masih berapa dia? 100. 100 kali dengan any motion in the y directions. In this case, no motion in the y direction. So it's equal to 0. Plus Fy dt. Okay. Any forces in the y directions. So kita ada NC, W, NC upward. Campur NC kalikan dengan what is the time interval T which is given 10 seconds, which is applied to the stone for 10 seconds. So makna dia this is the integral of F dt within 10 seconds. C kali 10 tolak W 981 okay. Plus what else? NC 981 kalikan dengan 10, NC kali dengan 10. We have another one which is 200 sin 45 degree. Is equal to M V to Y, no motions in the Y direction. So it's mean that V to Y is equal to because it's moved on a small horizontal surface at stone. So if you look at this one, we only have one unknown which is NC. You saw at the end you got the NC which is equal to 840 Newton. In 840 Newton. And this what we call normal force. So here is the solution as well. Since no motion occurs in the y direction, direct applications of equilibrium equations, sum of Fy is equal to 0, gives the same result for the NC. We can also apply this equation for the uh, Newton's second law of motion, which is a kinetic equation of motion, in order to solve this. So we have an additional question of acceleration. Determine its accelerations a and distance s. Okay. Determine accelerations a and distance s. You can try to do it at home by using this what so called it's actually when you want to get all this kind of thing, flashback, or you need to remember on what you have learned in the previous, apply the appropriate method in getting all these kind of things. Okay, we have an example two of okay, example two, 15. The 15 megagram box car A is coasting at 1.5 meter per second on the horizontal track when it encounters a 12 megagram tank B coasting at 0.75 meter per second toward it. If the cars meet and couple together, determine A, the speed of both cars just after decoupling. B, the average force between them if coupling takes place in 0.8 seconds. So kita ada dua. One is a box car and another one is track. On the horizontal track when the 15 megagrams box car. This one is a box car. Satu lagi adalah we have this tank B. The 15 megagram box car A is coasting at 1.5 meter per second on the horizontal track when it encountered 12,000 megagram tank B coasting at 0.75 meter per second toward it. If the cars meet and couple together, it means that once both move, one move to the rightward, another one move to the leftward. At the end, it will collapse between one to each other. No collision occur on that meeting of both of this box car A and also tank B. If the car meet and couple together, it means after meet, it's coupled together. They stick.